Hello there, it's Alana Tuckey, and I'm here to help with section 8.1, number 25. Okay, so let me click on View an Example here. Alright, so the shape of the distribution of the time required to get an oil change at a 15-minute oil change facility is unknown. However, records indicate that the mean time is 16.5 minutes and the standard deviation is 5.4 minutes. Complete parts A through C below. Okay, well, if we're going to compute any kind of probabilities, we need to know that this is normal. Right? So we would have to have a normal distribution. Wonderful. All right, so to compute the probabilities regarding the sample mean using the normal, what sample size would be required? Oh, okay. So remember for means, let me pull up the notes real quick. There it is. We remember in order to create a let me put it this way. In order for the sampling distribution of the sample mean to be normal, you have to have a large enough sample size. And in our course, we're basically just fudging it, and it's just going to be larger than 30. As long as your sample size is larger than 30 for a mean. Now, this is not true for proportions. That's section 8.2. That we need a bigger data set, or we need a bigger data sample, excuse me. But we've got to have a sample that is larger than 30. So let me put that down. So for part A, we would need a sample size larger than 30 in order to ensure that the sampling distribution of sample means is normally, approximately, it's not really, but it's approximately normally distributed. Right? We want the normal curve. And in order to get the normal curve, you're going to have a big enough sample to ensure that. Again, for means, that'll be 30 or more, or for proportions, that'll be something else. Now, if they tell you somewhere in the problem that it's normal, then you can have sample size of 3 for all we care. The trick is that it says that the shape of the distribution, blah, 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 is unknown. So you don't know that it's normal. If you don't know that it's normal, it's got to be 30, right? So since the shape of the distribution is unknown, we would need a sample size of larger than 30. Well, I guess equal to, sample size of at least 30, because 30 is okay, but less than 30 is no good. In order to ensure that the sampling distribution of sample means is approximately normally distributed, got to have at least 30. Again, if you knew it was normal to begin with, you could do 2, 3, 4, whatever. Doesn't matter. But if it's not known to begin with, if it's unknown, then you've got to have 30 or more. But again, this is only true for means. So if it's unknown, you need 30 or more, but only true for means. If it's proportions, you got other issues. Okay, so then, let's see what they have to say. Okay, so, hey, look at that, equal 30. There we go. So part B, what is the probability that a random sample of, look at that, n equals 45. Okay, so n equals 45 means that we're talking about bigger than 30, this is going to be normal. Let's make some notes to ourselves. Since n equals little n equals 45, that means that we're going to have shape normal because n equals 45 is greater than 30. We're going to have a center, which is going to be mu, which is equal to, actually, the mu sub x bars. It's the mean of all the means. So the mean of the means is equal to mu. I gotta get the little bar over his head. There we go. Is equal to mu, which was equal to, I don't remember. Mu was 16.5. Okay, so mu is 16.5. Beautiful. There's the center. Now the spread is equal to, oh goodness, there we go. There's a formula for it. This is called the standard error. Here, let me call it. Spread is equal to standard error of the mean. It's sort of the sampling standard deviation, but it's not really. It's the standard deviation of the sampling distribution. So it's called the standard error. Now the formula for it, sigma sub x bar, which the formula is sigma over the square root of n. right? And then that would be, let's see, what was the sigma? Sigma was 5.4. Okay, so this would be 5.4 divided by the square root of 45 because n is 45. And that would give us approximately, let me pull up a calculator here, 5.4 divided by the second square root 45, enter, 0.80498. Yes, you do want to keep, plenty of decimal places, so how would we do like 0.805? That'll be good enough for now. 805. Beautiful. Okay, so this is all just preparation work. I haven't really solved the problem or anything. All I'm doing is preparing myself for what I'm going to have to do. So I now know that's normal. Once I know it's normal, I can use all the techniques from chapter 7 to find whatever I'm looking for. I know the center of that normal curve, and I know its spread is 0.805. Cool. Now to catch that, the original one had a spread of 5.4. That's individuals. But the sampling distribution, when you start looking at groups of 45 and their average, so take one group of 45's average and the next group of 45's average, the next group of 45 oil changes average, they should only be about 0.805 minutes apart. Very, very, very small because you're grouping so many different oil changes together. All right, now the question actually asked, let's see. What is the probability that a random sample of n equals 45 oil changes results in a sample mean less than 15 minutes? Okay, so what are the chances of your sample mean for 45 being less than 15? So we're looking for the probability that x bar, the sample mean, not a single oil change. I'm not talking about one oil change being less than 15. I'm talking about a group of 45 having an average of less than 15 minutes. What is that? That's the question. All right, so there's a few ways we can do this. I'm going to start with StatCrunch because StatCrunch will be the easiest and best way to do it. All right, so I go to StatCrunch, go to Stat, Calculators, Normal. Now the mean we just figured out was equal to 16.5. The mean is what mu was for the data set, but the standard deviation is 0.805. And then, now remember, are you trying to look for a bar or for an area? This guy over here is the area, this guy over here is the vertical bar. But it said, what is the probability? That means you're looking for the area under the curve. So this is the part you're looking for, and this is where you're going to put 15. And there you go. Look at that. So the middle is 16.5. You got this over here at 15. Just curious if that's better. No, it doesn't really matter. Either way is good. All right, so there's 15. There's the area. So let me copy that image and paste it in. Oh, I always forget. Paste special. There we go. So the probability is 0.0312, more or less. All right. Now, what if you were going to find that with Excel or the calculator? Well, let's use the calculator. So the calculator, you're looking for the area. So you're going to use normal CDF, number 2. And then you want the left-hand edge of what you shaded, which in this case was negative infinity, because this goes on forever and ever. So negative infinity, which is negative 1e99. Calculator can't handle negative infinity. The upper hand edge, remember, was 15 because you want to be less than 15 minutes. The mean was 16.5 minutes, but the standard deviation was only 0.805. Go down to paste, enter, enter, and there you go. Same as what StatCrunch came up with. It's a thing of beauty, isn't it? And just in case you're curious about Excel, even though, again, we basically won't use Excel from this point on, but if you want to know how to do it, I can show you. Oops, I just need a new window here. Okay, so remember the left-hand edge. Let me start with this. The mean was 16.5. The standard deviation, I actually, let me do this. The standard deviation was 5.4. The standard, sample size. Sample size was 45. I'm just going to show you this calculation in Excel if you wanted it. Standard error is equal to 5.4 divided by SQRT of 45. There you have it. Okay, so then to find, and our X value is 15 minutes, right? So I want the probability that X bar is less than 15. That would be equal to norm.dist, here, let me do it down here, equals norm.dist of, and it wants the X value, which was 15, the mean, which was 16.5, the standard deviation. Now it says standard deviation, but in this case it's not appropriate to use standard deviation. You actually want standard error because you're talking about a group of 45, and you say true. All right, and then let me just type that up for everybody. It was norm dist 15, 16.5, 0.805, true. And that's how you do it there. Again, you can start seeing this is why Excel is such a pain at this point. It's really not doing anything nicely that we want anymore. So at this point, this is one of the last videos you'll probably see with Excel because we just don't like it. It's not as clean as either the calculator or StatCrunch. Okay, so that's how to do that part. Let's see what else do they want. So that's part B. So they find the mean, look there, they found the standard error right there. There's the area, 0.03, just like we said. Okay, so now they said, suppose the manager agrees to pay each employee a $50 bonus if they meet a certain goal. On a typical Saturday, the oil change facility will perform 40 oil changes between 10 a.m. and 12 p.m. Treating this as a random sample, what mean oil change time would there be a 10% chance of being below? Okay, so we're looking for the time and we're given an area of 10%. So they want to be on the low side. Oil changes want to be quick, so they want to be low time. All right, so we got to do all this again, unfortunately, because the problem is different for part C. For part C, we're talking about N is 40. Still normal because 40 is greater than 30. The mean is still 16.5, but your standard error is going to be different because it's going to be 5.4 divided by the square root of 40. So we find that 5.4 divided by square root 40. Enter. That's 0.8538. So 8538, which is 854, let's say. Okay. So now we need to find the score given that the bottom 10% is what we're looking at. So let me close this. So this is still 16.5, but this is going to be 854. Not that one. 854, sorry, 854. So let me go back. Oops. Go to the wrong place. 854. Now I'm looking for the cutoff score, but I know that I want the bottom to be 10%. Compute. So this red area right here, that's worth 10%. And look, it found the cutoff time for me. Right there, 15.4. Oh, oops, I'll be right back. There we go. So the cutoff score for the bottom 10% will be 15.41 minutes. Let's see if the calculator backs us up on this. So I would use second distribution, inverse norm. I want 0.10, I want 16.5, and then I want, it was 0.854. Paste, enter. And there you have it. All right, there it is pasted in, and hopefully that's everything we need. There we go. Yep, that's it, 15.4 minutes, just like I said it was. All right, I hope that helps with that problem. And notice I didn't bother with Excel for the last one because if you haven't caught on, Excel is basically useless at this point. So enjoy it.